All right, last video of the year, last set of notes in the stats before we get to exams and all that stuff. So enjoy it. It's been a good one. It's been a lot of videos, but it's been a good, tough year. So glad y'all made it. Glad you're still sticking with it. So the last thing we're going to talk about here is this difference in theoretical versus experimental probability. So some background, some definition. So a sample space is going to be a set of all the possible outcomes of your experiment. An event is any set of the outcomes. Theoretical probability is what should happen. Experimental probability is what happens after we measured it. So it's very important that you keep running trials of an experiment. Your experimental probability will get closer to the theoretical probability as you keep doing more and more and more. So the sum of all the probabilities is always 1 or 100%. Or is add and is multiply. So some words that you see here. Complement is the set of all non-favorable outcomes. So it's the probability of not A, and that's equal to 1 minus the probability. So pretty much this is everything except EXEPT, what I want. And the formula for the equation for likely outcomes is the probability of the number of favorable outcomes over the number in your sample space. So that's kind of the formulas we're going to use here. All right, so theoretical versus probability. So here, we're going to kind of take a look at this. So flip a coin 5 times and record your results. Yours might be a little bit different than me. When I just flipped a coin 5 times, I got tails, I got heads, and I got tails, and I got heads. So the theoretical probability of the trials, you're either going to get 1 out of 2 or that's 50%. Because you're either flipping, you're going to get a heads or a tails. The experimental, I got tails, I got 3 out of the 5. So that's 60%. All right, I'm going to use some data from last year's class since obviously I'm making a video. So the number of heads we got in the class, we got 70. Total of tails, we got 65. Total number of trials, that's 135 flips. So the class theoretical probability is still 50% because you're either going to get tails or heads. The experimental would be 65 over 135, which is 48.148%. So what do you notice? When we use more trials, the experimental gets closer to, so with more trials, the experimental gets closer to the theoretical. And that's what I want you to see here. All right, so let's take a look at this. So finding some theoretical probability here. So you got a quarter, you got a nickel, and a penny, and you're flipping them all. So find the probability of each of the following here. So the quarter shows heads. So you got a quarter, a nickel, and a penny, or flip. Find the probability that the quarter shows heads. So I got the quarter and the nickel and the penny. Okay? Now I'm going to put the words and so you can see these. Quarter and a nickel and a penny. So I'm using the word and, so that means multiply. So the quarter, I got a 1 out of 2 shot. Because I want to show heads, but it could show tails. I don't care what the nickel says, and I don't care what the penny says. So multiply them together. 1/2 times 1 times 1 is 1/2, so that's 50%. All 3 coins are tails. So I'm going to go in the same order. So the quarter could be 1/2. The nickel could be 1/2. The penny could be 1/2. So if I multiply all that together, I get 1 out of 8, which is 12.5%. Cool. All right, the penny and nickel show heads. So I don't care about the quarter. The nickel could be heads or tails. The penny could be heads or tails. So that would be, 1/4, which is roughly 25%. The reason I'm saying 1 for the quarter is it doesn't matter if the quarter is heads or tails. So now all 3 coins land the same way. Either all heads or all tails. So all heads or all tails. So or, remember, or here means add. So 1 out of 8 or 1 out of 8 All my different options here. If I look above it, all three are tails, that's a 1/8 chance. All three are heads are the same thing. So that's going to be 2/8, which is 1/4, which is 25%. So kind of looking at a few things on probability, kind of looking at this. All right, let's come over here. So I have a CD, has 5 upbeat songs and 7 slow ballads. What is the probability that a random selected song is an upbeat dance song? So the CD is made up of this. So my total here is 12 songs. So how many upbeat songs are out of the 12? 5 out of the 12, and you get 0.416 repeating, so 41.67% chance it's going to be an upbeat song. Cool. All right, so I got number cubes over here, different colors, different numbers. I got 2 of them, so I'm rolling 2 of them. So a red number cube and a blue number cube are rolled. If all the numbers are equally likely, what is the probability that the sum is 10? So what I want to do, there's 36 total. How many add up to 10? If so, I'm looking at that. I got 1, 2, 3, and that's it. So 3 out of 36, which is 1 out of 13. Sorry, it's 1 out of 12. And that's going to give me 0.833, so 8.33%. All right, let me erase my scribble over here. What's the probability that the sum is 6? So how many add up to equal 6? So 1, 2, 3, you'll see patterns, 5. Anything else? Nope. So 5 out of 36, which is 0.138. So 13.89%. All right, let's try erase that. So what's the probability that the difference is 2? So that is subtract to give you 2. You're looking at here, this subtracts to give you 2. No more here. No more that one. This one. This one. And I found my pattern. So what's that, 8? So 8 out of 36, which is 2 out of 9, which is 0.222, so 22.22%. I like these where you can count them and you can actually see. All right, last one. Let's do blue. No, let's do orange. The red cube is greater than the blue cube. So where are the red cubes greater than the blue cube? So here, 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 and here. So how many do I got here? That's 5, 11, 12, 13, 14, 15 out of your 36. So that gives me 0.4167, so 41.67%. Cool. All right, so that's your probability. So let's look at this. That was all theoretical because that's what could happen. So let's find some experimental probability. So a bar graph shows the results of 100 tosses of oddly shaped number cubes. And let's see what happens. So what's the probability of rolling a 3? So first of all, how many do I have? I have 100 rolls, so that's my total. So what's the probability of rolling a 3? So 16 rolled a 3 out of 100, so that's 16%. What's the probability of rolling a perfect square? So my perfect square is 1 squared is 1, 2 squared is 4, 3 squared is 9. Nothing's going to happen. So those are my options here. So 1 and 4. So 17 plus 11 over 100. So I got 28 over 100. So 28%. All right. What is the probability of rolling a number other than 5? So not 5. I'll show you 2 ways to do this. So one way would be adding up all the numbers. So 17 plus 21 plus 16 plus 11 plus 13 over 100. So if I add those up together, 17, 21, 16, 11, 13, that gives me a 78. So 78%. since 5 is the only one there, I could find the probability of 5, and that would be 22 out of 100. And then I could have taken that and subtracted it and got your 78% as well. So you could find the probability of finding 5 and actually getting 5, and then taking that away from 100, and that will give you the same thing. So explain how this is different, or it's experimental, because the dice were rolled. So that's how you get the different number of trials. So if this helps, we're going to practice, and then we'll get ready for our last test and then exams. So I hope you have a wonderful day, and let me know if you have any questions, and I'll talk to you later.